Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar discussing integrating service enclosures in slabs and pavements. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's long-standing industry partner, ECHO. ECHO in Australia offers an extensive portfolio of stormwater, building drainage systems, cable pit and ducting systems, access covers and other niche products. ECHO takes pride in providing excellent customer service and extensive technical support from specification to the finished product installation. Today, we will hear from two speakers, followed by a live audience Q&A, and encourage you to send questions through to our speakers via the YouTube chat box. I'd now like to welcome our first speaker, Maurice Belcher, Senior Associate Electrical Engineer at Jacobs. Maurice is a principal engineer and project management professional with over 25 years of electrical engineering, design reviews and verification and project management experience. Maurice has provided electrical engineering services including concept design, detail design, construction support and technical advice on a diverse range of projects. His strengths include good communication skills, multidiscipline coordination, control system integration, project planning, along with a track record of design management and project management. Please welcome Maurice Belcher.
Well, thank you for that introduction. It's much appreciated. Good afternoon, and thank you for joining the Engineers Australia's webinar. My name's Maurice Belcher, and I'm an associate electrical engineer with Jacobs, and I'm going to discuss the integration of electrical services in foundation slabs and pavements. I'll be addressing the design requirements and the electrical compliance issues. Then I'll be handing over to Darren, and he will be covering the installation, location, mechanical loading issues. Essentially, I'm going to talk about all the issues, and Darren's going to give us all the answers, hopefully. So I'm going to structure this presentation by talking about an overview of the medium voltage, low voltage and communications infrastructure. I'm going to talk about electrical design drivers and issues and constraints. Then I'm going to finish off with the safety, security, and some anecdotal information about existing systems. Before we start, I'm going to have a brief introduction about Jacobs. I'm part of the transmission and distribution group, and there's our company mantra at the bottom left-hand corner there. We're challenging today and reinventing tomorrow. We're a global group, and we cover many. This slide shows some of the breadth of our company, but I sit right in the middle there. You might be able to see there the engineering and design section there. But this side is intended to just show that breadth of skills that we have within the company. This also shows some of the capabilities of Jacobs. We've got their generation group, the transmission and storage distribution group, and I'm part of the integration energy solutions group there on the right hand side. So that's the part of the world I sit in. And this shows our global company profile. You can see there that the majority of the Jacobs people are in the US. There's 34,000 people there, 250 in the energy and power sector, and that's a reflection of the global team. And I sit obviously in the APAC area there. I'm one of the 405 energy and power people within the ANZ area. So now I'm going to start talking about some of my experiences with the infrastructure. And as I said earlier, I'm going to structure it between the medium voltage, the low voltage and communications. And I'm also going to show the above ground issues and the below ground issues. So here's some examples, and I'm quite pleased with the one on the top, the left-hand corner there, because I took that photograph on my morning walk where you could see some medium voltage infrastructure on the street side. And these are commonly seen on the street. And another key point to note there in the bottom left-hand corner is some of the cover there for some medium voltage cables that will go into the substation. You can see the vehicle there, and I think Darren's going to talk about the loadings for traffic in his presentation. You also see in the middle bottom presentation there some of the covers for the cable pits under construction, and there on the bottom right hand corner I'd just like to point out that how the option of using multiple covers to provide a cover and access to a very large pit. So this slide shows some of the infrastructure, and this is where we get into those penetrations that the presentation's all about. Very large purpose-made concrete formed pit on the top left-hand side there, and then you can see some of the conduits that go through the foundation, and then the bottom left there, it's possibly not that clear to see, but you can see the use of the bell mouth penetrations there, so that the penetrations provide a smooth access for pulling those cables in and into the pit, and ultimately into in this case, a substation. In the bottom right-hand side there, I've shown some examples of sealing. One of the biggest issues that we have with in-ground infrastructure and the penetration through the slabs and pavements is water egress. And there's a good example of how spare conduits and the conduits in that left-hand side are sealed with a proprietary product to give you both watertight and a fire rating through those penetrations. And another option in that top right hand corner is the penetrations that come up into basement areas onto cable ladder, and then in that case up to the high voltage switchboard, which is immediately above it. So this slide, I just want to talk a little bit about some of the infrastructure that is inside those enclosures. It's quite amazing how much equipment is condensed into a small footprint. And you can see there on the top left is my favorite walking picture again, and you can see there some of the design issues that underneath that enclosure there'll be a pit to enable the cables to bend and get in and out of that ring main unit. and in the right hand side you can see just how close a lot of those cables that are that are terminating into that enclosure. Down in the bottom left you can see a kiosk transformer, and you can see there in the image on the right hand side, you can see the high voltage equipment on the left hand and the low voltage equipment on the right hand side. So they're pretty busy installations. We're moving on to the low voltage equipment now, and here's a few examples of infrastructure where the cables of low voltage cable pits, and above ground, you can see there in the top left hand side a what I'd call a distribution pillar where there'll be some LV potential fuses in there that feed infrastructure. And then the one in the middle, which I took it during my morning commute through the railway station, you can see a pit there, and you can see where it's had that nice finish over the top, so that you've got an architectural finish as opposed to the industrial finish. The other one on the right hand side is you can see just how solid those cable pits are. Now this is inside the LV pits, and I was just trying to demonstrate those cables and bending radiuses that we'll talk about a little bit more when we are talking about design issues. But yeah, there's some examples of LV foundations, and particularly that one on the right hand side where the cables actually transition in two different planes. Not only is it going east to west, but also going vertically as well. So it's yeah, particularly when you're specifying these things, are often the use of 3D software that is commonly used nowadays to understand those types of issues is quite useful. Now the communications pits, here's some examples. I chose the one on the left hand side to again from my walk in my morning walks, but that shows the vicinity of the communications equipment to the LV pillars. So it's a good example of the segregation and the spacing of services. The image in the middle was intended to show just how cable pits, in this case it's a comms pit, can seamlessly integrate into the paving, the finish of the pavers. There's another example on the right hand side that you might be familiar with seeing, is the Telstra distribution pits in the roadsides. So now I'm going to talk about some of the engineering issues, particularly with respect to the cable radii for medium voltage LV and communications. We're going to talk about the segregation. I'm also going to show an example of a calculation software that Jacob used for the pulling of large cables. And I'm also going to talk about issues with respect to water and wildlife egress. So this is a snapshot of an HV cable pit, and you can see there where this is out of a specification where we're specifying this particular pit from a plan perspective on the left hand side, and then an elevation on the right hand side. A few key things to note is the obviously the size. It's rather large, and also ladder and the access lid. Obviously, there's multiple versions that could be used for that lid. As we talked about in those earlier slides, they could be multiple smaller panels. It could be one heavier panel with a small access penetration. So there's lots of variations to that. But the key things that I'd like to note here is the um, the digital use of the datum point in the middle of the pit there, so that it's physically located from a northings and eastings perspective. And also the note that there's spare conduits in there. You could see in that bottom right hand image where there's two conduits that have been have cables allocated to them, and we have spare conduits. So that's a key principle, I guess, is that if you're spending a lot of money with the civil infrastructure to put these pits in, the cost, the incremental cost of some spare conduits is it's smart engineering to make sure that you have some spare capacity there. So moving on to this one, this is an LV, and in particular, I like the use of our modelers and designers here, where they've used colour to differentiate between the HV and the LV services. You could see here it's an example of how we've labelled each of the conduits and each of the pits, and there's some key schedules when we document this equipment as to what cables go in each conduit, and so that the installers know which are the spare conduits, which are not, which cables we're expecting, and because we've taken into account all of the bends. So the key thing to take away, obviously, as our cables get smaller, the size of the pits get smaller, and the bending radius is slightly less. Now we've got even smaller. This is a 600 by 600 pit. I know we've shown it as a concrete pit, but there's, and this is something that Darren may talk about, is the different materials that can potentially be used there, depending on its location within your site. But there's a communications pit that's obviously a lot smaller. So now I'd like to just address the segregation issues. There's some key tables within AS3000 that need a good reference, and we need to comply with to meet compliance, and that's in section 3.11.4.1. And there's table 3.6, which is the segregation of depth of segregation between services. And then the table on the right is the separation as in horizontally between various services. So that's certainly the starting point to make sure you comply with that. And I would say, though, that these are the minimum requirements. It's always I always think that that's the minimum. So if you can actually have a little bit of additional clearance, that can't hurt. Obviously, you don't want to put any additional expense on the project because civil works are expensive, but often clients will have clear requirements that go above and beyond these minimum requirements. I'll also reference there 2067. That's our high voltage substation standard. There's some clauses in there about clearances. I'll also reference AS NZS 3835. That's more to do with communications and the clearances between buried earth electrodes and things. I've noted there AS 3996. I think Darren's going to talk about that. So I'll pass that over to Darren when we get to that point. Here's the example of the cable pulling that I talked about. I got to confess, I personally don't use this software, but there are people within Jacobs who use this, and this is obviously ideal for very large cables that are typically high voltage, very heavy, and the, the principle is to understand exactly how you're going to pull these cables, how many bends there are, how that friction, the coefficient of friction is going to work, and just how much tension. You don't want to damage your cables when you're pulling them in. So here's an example of that the software actually you model the pulling, and it can actually tell you that the tension that's required, and interestingly, just the quantity of lubricant that's required. And you can see there in the table that it takes into account all of the horizontal bends and the key vertical bends as well, because in any electrical infrastructure, that's the key part where you're coming out of an electrical device, going down into the ground, and then coming back up into a device. Now we're getting near the end. I'd like to just talk a little bit about safety and security. So these images here sort of gives you an indication of the weight of these units, and particularly the middle one there that has obviously been defined as a confined space. So there's key safety issues that need to be taken into account before climbing into those types of pits. Certainly from a lifting and manual handling point of view, the one on the right-hand side, it just goes as a good illustration of the purpose-made lifting equipment that you need to use to lift those lids. And the one on the left-hand side is really just to show the indication of the weight. As I've said there, I've just got a one-liner underneath there with respect to removing any existing covers. If you are on an existing site, just beware of the wildlife, and yeah, the rodents seem to find a nice cozy spot underneath there. Another issue that I'll talk about here is just briefly security and the ability to have lockable attachments to the enclosure covers. Darren might talk a little bit more about that in his presentation, but definitely in public areas and defence requirements, there are dedicated locking provisions so that people can't get into these types of enclosures. This is just an example of some of the existing sites. Yeah, water is an issue, and often when you open pits and enclosures that haven't been open for some time. There's always a surprise or two waiting. Don't be surprised if there's cable joints that you weren't aware of, or things in the pit that have evolved over time. Also, it's on the right-hand side there, yes, some issues with respect to some subsidence associated with your existing pits that you might need to be aware of over time, so that they don't become trip hazards. So in summary, I've talked about the overall electrical issues for MV, LV and comms. We've talked about the electrical design drivers with respect to the cable bending radiuses, the segregation compliance requirements. We've talked about safety and security, yeah, we've covered quite a few topics. Before I finish, I'd like to have a shout out to those who helped me prepare this presentation. There's Tim from our Brisbane office, Skulk from the Perth office, and Bernard from our Jacobs Melbourne office. So thank you guys. And also a special shout out to Jared and Rose from the Sunwater uh, Energy Services team. Thank you for your inspiration. And just before I hand over to Darren, the lights have come back up. I'd just like to shout out to, considering the day we have, is to make sure we to go Queensland. I'm sure Darren will have some come back to that one. So thank you all for attending, and I look forward to you answering your questions in the Q&A. Thank you.
Thank you, Maurice, for a great presentation. And now let's welcome our second and final speaker, Darren Chan, Brand Manager at Echo. Darren is the Brand Manager at Echo for Civil Construction Products and the NATO authorised representative for Echo's testing laboratory. At Echo, they continue to support engineers and designers with innovative products and free online design tools. Please welcome Darren Chan.
Thanks for the introduction. Good afternoon, everyone. My name is Darren Chan, and I'm the Brand Manager for Echo Civil Construction Products. Before I go on, I want to thank Engineers Australia for facilitating this webinar and Maurice for an excellent presentation. So today we're going to look at service enclosures. Bits and covers are necessary elements of any power or communication infrastructure to give authorised access to cables and other equipment. But a lack of detailed specification will invariably lead to issues of durability and performance. Today, I'd like you to walk away with an appreciation that there are many types of enclosures, which is why specification is important. Lids and access covers too are key elements. They take the direct loads and they are the movable and visible part of the enclosure. Correctly specified service enclosures can be installed in any project application, from residential to the urban and civil environment. They comprise a choice of different manufactured materials with various type of lid or cover options. And these are just a few pictures of pit failures to show why correct specification is important. Incorrect product selection for a particular project or poor product design can lead to failure. Failures might occur for a variety of reasons, but understanding all the aspects of the enclosure system is critical to long-term performance. Let's start with the specifiable elements, beginning with the fundamentals. Cable surface enclosures are positioned on cable routes. Bits are dotted along these cable routes to allow for cables to branch out or bend in different directions. The bits can also allow for cable jointing. Surface cable ducting systems, on the other hand, continuously follow the cable route. They are in effect the cable route. Some specialty pits can serve niche functions like housing transformers and other equipment. Here are the main functions for cable enclosures. Pits are used when a cable run needs to change direction. The cable exits before and re-enters the conduit after the bend. Conduits can be installed on gentle bends, but for sharp bends, a cable pit is required. Also known as pulling boxes, pits can be used for drawing or hauling cables. Cables can be looped and heaped into one enclosure and then fed into the conduit to be pulled to the next enclosure. Jointing pits, also called splice boxes, are for enclosing a spliced cable connection. These cable pits must be correctly sized to accommodate the cables running through it as well as the size of the connector. What type of cables are we talking about? Anything from data transfer to power supply. Enclosures can also be used for transformers, pumps, valves, and stormwater junctions. So from an engineer's perspective, enclosures are there to protect from unauthorized access by acting as a shield to prevent potentially live elements from injuring people, animals, and property, or even cables from interfering with each other. But fundamentally, enclosures need to provide physical protection to cables and equipment. With the resale value of copper, this also includes theft. Some factors to consider before specifying enclosures. Critical is the spatial capacity of the enclosure, its location by understanding all the intended loads along the cable route. Engineers must also consider the level of security that's required together with any unique site constraints, and most importantly, the requirements of the asset owner. Choosing the correct enclosure size will depend on a number of factors like the function of the enclosure, the quantity of cables, whether the enclosure is to be used to store equipment or cabling for future infrastructure rollouts, the minimum bending radius of the cables, the minimum cover depth that's required to the cables, and if cables need to be segregated. The manufacturer always needs to provide clear working area dimensions. Please bear in mind, most cable pits are narrower at the base for ease of manufacturing. There is no Australian standard that applies to service pits. Designers need to consider the anticipated traffic scenario over each enclosure, whether it be none, accidental, or deliberate, and what wheel types and loads during construction and during service. Remember, a single cable route can pass through several different environments, and every service pit along the cable route may be exposed to a different traffic scenario. A lack of consideration can lead to over-design or failure. There are different materials which can have a bearing on an enclosure's durability. This needs to be assessed against the project requirements. Common materials include polymer concrete, cast in situ or precast, plastic, polyethylene or polypropylene, and GRC, glass reinforced concrete. Correct installation and the durability of the adjacent supporting pavement is also critical for the enclosure's design life. Pits are commonly manufactured from polymer concrete. This is a strong composite material. It's lightweight compared to concrete. It's smooth, great for chemical resistance, and is non-flammable. With plastic pits, the most common are molded from polypropylene and polyethylene. These are lightweight, have really smooth walls, and also great for chemical resistance. But they are flammable and have a low resistance to weathering and a high coefficient of thermal expansion, meaning they behave quite differently to the pavement surrounding it. Plastic pits can be single-walled or double-walled, which provides a much stronger solution than a single-walled product. Concrete is another option, and pits are reinforced with steel to give them strength. These are heavy but strong and non-combustible. GRC is glass reinforced concrete, an aggressive environments, thin wall GRC is prone to deterioration, particularly in alkaline soils. So GRC pits require regular maintenance and in some cases are susceptible to early failure. It's also a porous material, so really not the best option for electrical enclosures. A correctly installed enclosure is critical for long-term performance. Depending on the application and the pit material, a cement concrete encasement and/or trafficable concrete collar may be required. Some pits require bracing prior to compaction. Multiple conduit entries can comprise the strength of a pit that this must be compensated for. Manufacturers should provide typical installation drawings and installation methodologies as well as recommended minimum conduit spacing on a pit wall. Soils apply lateral pressure on structures. This can be from their own weight, surface live loads, for example vehicles, and expansive soil properties. The resulting lateral earth pressure exerted on the pit wall in a horizontal direction. Its magnitude is a function of the shear strength parameter of the soil. For instance, based on a live load of 8 tons from half an axle, this can result in a side load of 435 kilograms for a 900 by 900 by 750 millimeter deep pit. This is the linear load distributed along the vertical height of the pit. Manufacturers should provide evidence of sidewall strength. The arrangement of conduits within the cable route will determine how many penetrations are required on the walls of the enclosure. Factors that can determine the maximum quantity of conduit penetrations a pit will accommodate depend on the pit material type, pit size, and frequency of traffic. A build-up of silt is common in cable pits and can make cables difficult to access, so penetrations should be sealed and conduits should be placed above the base of the pit to avoid damage to the cables. For each enclosure type, manufacturers should give guidance on the maximum number of conduit penetrations and spacing between each. An enclosure's material type and wall design can dictate where pits can be installed and whether a collar or concrete encasement is required. In general, enclosures with single thin flexible walls such as plastic pits should only be installed in light-duty areas. Where there's vehicular traffic, all thin-wall pits should only be considered as sacrificial formwork. Concrete or double-walled plastic pits, however, have good structural strength. As I mentioned before, people must be protected from cables, and cables are to be protected from people. Enclosures design must take this into account. The asset owner is not only stakeholder, the needs of the public and maintenance crew are also important. The importance of which varies from project to project. For instance, there are very sensitive areas associated with defence projects, which must be secured at a high level for obvious reasons. In these instances, pits need to comply with SCEC. SCEC is a government entity that works across government departments responsible for the evaluation of security equipment. Its function is to assess the suitability of products to meet government security requirements. Suitability is measured in the time it takes to break into a service pit. Products that obtain SCEC endorsement are placed in the SCEC's CEPAL catalogue, available only to SCEC consultants. There are 4 levels of SCEC endorsements. SL1 and SL2 relate to trafficable enclosures. An example of where these enclosures are used is at the Australian War Memorial in Canberra. Designers for the ICON network were only permitted to use SCEC-endorsed cable pits. For this project, security level 1 cable pits were specified and installed. Metal components within the enclosure should be kept away from electrical cables. The absence of metal locking bars are the best solution. If required, pits should be connected to the earthing structure of a building or construction via an earthing strap eye. Service enclosures are not designed to be waterproof. A reasonable degree of weather resistance can be achieved by sealing edges of covers and capping lifting holes each time the cover is removed for servicing. Adjacent pavement should be designed to fall away from the top of a pit. Pit drainage is recommended, particularly for pits positioned at the low sag points of a pavement to prevent them from filling up with water. There is a large range of cable management accessories that can be used in enclosures to protect, hang, and segregate cables. Enclosures can be supplied in pieces to install around pre-existing cables, and these are called split pits. Lids and access covers, these are the physical barriers that come in contact with the external environment. As I mentioned before, there is no Australian standard that applies entirely to service pits. AS 3996 does, however, govern access covers and lids as the bearing elements of direct live loads. This standard was revised in 2019, and compared to the 2006 version, lids and access covers have stricter deflection criteria, and Class D has increased from 210 kilonewtons to 240 kilonewtons for the ultimate load. There are 7 load classes defined by the standard, A to G. Durability and water tightness requirements are also included in AS 3996. Manufacturers should always provide NATA endorsed load test certificates for access covers and lids. A lid is positioned directly into the pit rebate, so any loading applied to the lid is supported by the pit. A lid is only available for light to medium loads, as the load is transferred directly to the pit walls. Access covers, on the other hand, comprises a separate cover and frame. The frame is supported by the pavement or slab, allowing the load to be transferred away from the pit. This is why access covers are used for heavy-duty applications. And to help with the design and integration of the cover into the pavement, manufacturers should provide typical separation dimensions between the pit and the access cover for different load scenarios. Do not confuse total vehicle weights with individual wheel loads. Service pits should not be placed in areas of fast-moving traffic, for example in roads. AS 3996 only offers guidance to designers for nominal wheel loads. Consider the axle exerting the greatest weight and divide by the number of wheels to reduce this load to only a single wheel load that will make contact on the lid. The key for worker safety is preventing foreign materials, like needles or reptiles, from entering the enclosure. The degree of protection that's required against objects entering a pit is expressed as an IP, or ingress protection rating. Manual handling requirements must be adhered to when lifting lids and access covers, so workers can make a safe assessment. Manufacturers should provide lifting weights on the cover itself, and heavy castings must have lifting anchors provided to safely lift the lid. Depending on the installation, certain requirements are considered critical to the asset owner or maintenance crew. These factors can determine the type of lid required. The top surface of all lids and covers should provide at least the same slip resistance as the adjacent pavement or meet the requirements of AS/NZS 4586 and HB 198. Identification is really important for maintenance crews and contractors carrying out future work. Manufacturers should be able to provide lids to meet these project-specific requirements. Depending on the security requirement of the cable route, lids are available in a number of security options: standard bolt, security bolt, padlocks, or high security SCEC padlocks. In non-sensitive areas, heavy access covers generally do not require locking bolts, particularly if frequent access is required. Manufacturers should be able to provide lids to meet the level of security required for your project. This final section is on cover and frame systems. On the main, access covers are made from either steel or iron. Iron is the most robust material. However, steel covers may better suit most floors and light-duty pavements. Plastic covers are also available in the industry, but are only used in very niche applications. Before making a selection for each application, one will need to assess all these factors on the screen, as their importance will vary from project to project. Manufacturers should provide guidance as to the best materials to use against critical project requirements. Aside from materials, there are many types of access covers with different shapes and configurations. Some are solid top, others require concrete infill. Solid top covers need to meet minimum slip resistance requirements. For infill covers, concrete may or may not be integral to the strength of the cover. Manufacturers should provide clear installation guides, particularly for covers requiring structural infill. Infill access covers allow visual continuity along the pavement floor. Decorative edging with stainless steel or brass trim will enhance the appearance of covers and frames. Edging for iron access covers is often standard if pavers or tiles are used. Manufacturers should offer the correct depth covers to ensure pavement materials can be supported. Here are some examples of infill covers both internally and externally. Access covers are specified by their clear opening. This is the unobstructed opening of the frame. Iron covers are only designed to move in one direction. They are specified by the width by length. The width is across the lifting points. The length is parallel to the direction of removal. When positioning access covers, ensure obstacles like walls do not impede the cover removal. Bottom image shows an incorrectly positioned access cover which will be difficult to remove. To avoid confusion, manufacturers must follow the standard width by length convention in their product tables. Width should always be specified first. Cover infill materials influence the lifting weight. AS3996 requires the cover to have permanent markings showing approximate mass of the cover, including any infill. According to Safe Work Australia, lifting, pulling and pushing requirements vary across each state and territory. Mechanical lifters, long and short handle keys are all designed for easy lifting. Manufacturers need to specify the approximate lifting weight on all access covers. Whilst access covers aren't designed to be waterproof, AS3996 gives performance criteria for gas and water tightness. Iron covers shown in the top image should be greased each time they open. In practice, this often doesn't happen, which means that over time the covers fuse with the frame and become harder to remove. So reminding maintenance crews that re-greasing is an important requirement after lifting covers. Now, galvanized covers do not require grease, as rubber seals are used on the underside of the cover. Bolts are required to fasten covers into the frame for security and/or if back pressure is anticipated. Particularly where there are gases, there's potential for uplift. In some instances, bolts need to be designed for the application. Stainless steel bolts are recommended for durability. Manufacturers need to provide calculation for structural bolts based on anticipated pressures. Multi-part access covers are a collection of single-part covers assembled together and supported by beams to span large enclosures. The beams and covers are all removable, so you can still access an enclosure without obstruction. It's important to note that AS3996 only governs single-part covers, not multi-parts. So each cover would need to be load rated to AS3996, not the assembly. Also, the beam, therefore, needs to be structurally designed. Manufacturers should recommend the beam size and bespoke system based on the total clear opening of the underlying enclosure. Trench fronts are surface ducting systems for wide and long trenches. They are custom built using the standard parts and pieces. Like multi-part systems, trench fronts can accommodate all types of flooring materials. Due to the number of removable components, including beams and individual covers, multi-parts access covers, by their very design, cannot be made watertight. Multi-part covers are suitable for applications requiring general weather resistance on well-drained enclosures. Multi-part installation requires careful planning. The load class and pit clear opening must be confirmed. The slab design needs to provide for the locations and depths of the beams and frames for the multi-part. To allow for this, manufacturers must provide rebate and cover scheduling drawings for every unique multi-part. You cannot install a multi-part without it. A rebate drawing must show the 4 essential elements and views described on the slide. To give you an appreciation of why correct planning is necessary, here is a quick overview of what is involved to install a multi-part. Step 1 is the pit preparation and frame setup and leveling. Step 2 involves inserting and leveling the beams and covers. Then the concrete pouring and finishing. Here is an example of a project at Brisbane Airport involving a heavy-duty enclosure requiring a multi-part cover system above valves in a fuel pipeline. Shut-off valves are strategically located along the pipelines. One of the shut-off valves is located airside between both terminals and is regularly trafficked by taxiing aircrafts. There are other more niche access cover solutions available in the industry, where regular access is required to utilities or machinery beneath, as an example. Covers can be hinged to the frame and a gas strut or hydraulic ram allows for easy opening. The system contains a rubber seal ensuring a gas and watertight seal. When opened, a galvanized steel safety gate falls into place and a stop latch holds the cover open to prevent the cover from accidentally closing. This is the end of the official CPD presentation, but I want to take another minute to explain what ACCO does. ACCO offer a wide range of pits, lids and access covers for general and niche project applications. These can be found on the website shown on the slide, accocablemate.com.au. In terms of product support, ACCO can offer you a personalised service to help you specify the right product in the correct way. We have installation drawings in PDF and DWG, Revit models, installation guides for each type of pit, and all of the specifics relating to that particular pit and material. ACCO has a technical representatives around Australia who are more than happy to assist you with your next project, either remotely or face-to-face. I want to take this opportunity to thank Engineers Australia for the opportunity to present today. A post-event email will be sent to you shortly containing all contact information. And thank you so much for taking time to attend this webinar today.
Thank you, Darren and Morris. It's now your turn to get involved. As always, if you could please ask our speakers questions via the chat box and who your question is directed to. Thank you to everyone who submitted questions whilst registering. Before we move into the Q&A, we're going to be running a poll. I encourage you to get involved. So if you could please scan the QR code on your screen or follow the link in the description box. The results will be shown on screen as you answer. Moving to question 1. When you are specifying lids or covers, what is the aspect in which you feel that you need more support knowledge? A, cover identification. B, security locking options, ease of access. C, slip resistance, pedestrian safety. D, pit material for durability, strength and sustainability. E, weatherproofing. F, aesthetics. That's great. Darren, do you want to comment on what's coming
Thanks
through?
for people participating in the poll. Yeah, this is just to help ACCO understand what's important for you engineers as designers, and we'll look to put these kind of features into our products. So it looks like the pit material for durability, strength, and sustainability is something that you guys find important. So we could look at ways we can develop our products to help with those requirements.
Thanks for that, Darren. We've only got 3 questions in total, so moving on to question 2, asking, in most of your projects, what pit construction have you specified approved? A, precast polymer concrete, B, precast cement concrete, C, concrete cast in place, D, moulded plastic. Vote now. Thank you. Well, just as the last few votes start coming in and get consolidated, Darren, do you want to comment?
That's very interesting to see that, concrete's the most popular. Obviously, it's a traditional material, and it's known for its durability over time. So it's good to understand that. Precast polymer concrete is polling really well too, which what ACCO makes. We also do molded plastics, but I suppose plastics are more for more niche installations, like for communications rollouts. So it looks like precast cement concrete is a product that we actually make with our SCEC product offering.
Thanks, Darren. And on to our final question. Thank you to everybody for participating. The question is, what support would you most value from a product manufacturer supplier? A, load certification of covers lids, installation drawings, pit sizing, BIM models. Thank you. Darren, I think the results are starting to settle. Do you want to comment?
Yeah, this is more, as ACCO, we pride ourselves on our technical support and what we can offer to the design community. So looking there with installation drawings, that's the most requested. I suppose that's what we want from manufacturers. We want installation drawings that show how to specify and detail the pits into your plans, and that's very critical to ensure a long-lasting, durable installation. And obviously, load certification is very important. At ACCO, we've got our own NATA accredited test facility, and we can provide NATA endorsed test certificates for our covers and lids, so you can be reassured if you come and specify ACCO's products, we can back it up with testing to the Australian standards 3996. And also, we're always looking to create more BIM models for our products, especially with all designs moving towards 3D modeling. We'll keep continuing to add more BIM models to our library. And obviously, pit sizing, you can always come to us and we can help you specify the correct size pits once we understand how many conduits are required, and what cabling is coming in and out of each wall of the pit. So, all these things are valuable for us, and we'll always look to improve our support for the design community.
Thank you, Darren, and thank you for participating in the polling. If you'd like to see more polling or other ideas you may have in these industry partner sessions, then please include in this feedback survey at the end of the session. Okay, so thank you to everybody we've had heaps of questions coming in, and also to everyone who put forward a question whilst registering. And I might give Darren a rest and start off with Morris. Morris, we've had a question from Giovanni, who is watching in Queensland. Good afternoon to you. Asking you, Morris, have you ever encountered and resolved issues by implementing a non-standard solution? Thanks, Morris.
Yeah, there's a couple of examples I can give of non-standard. I suppose if we consider standard being the fully enclosed pits with the conduits, and we've got an enclosed system, I've come across the situation where we had a hybrid system where for the contractor to install the equipment, we effectively had long straight sections where they could put the conduits and pre-bury the straight sections of conduits, but we left the corner sections open, and we applied the direct buried philosophy in that area. So that was a kind of a hybrid between a fully conduit system and but direct buried system where we get the benefit of both worlds. We had a number of road crossings in that particular project, so we needed the conduits to go across the road in those straight sections, but where we had the bends, the client accepted the potential, the cost savings and the practicality of them being buried direct. Another scenario was instead of using pits and conduits, that because of the size and quantity of cables, we've used culverts, which is basically a U-shaped bit of concrete with a lid on top. So that's another variant of the pits and conduits standard. Another, just a slightly different one, was where we a particular project where we had cables running from point A to B, and we made an allowance for a midpoint where there was going to be some new infrastructure installed at a later date, some planned new work. So there was a big coil of cable installed at that buried direct and labelled. It was in a client's facility, so it was nowhere near a public area. So that was quite unique as well, that this big loop of future cables, so that in the future, when the infrastructure or the kiosks were installed at their location, they could de-energize it, dig up that loop, cut the cable, and go in and out of the kiosk. So that was an example of a few unique situations.
Thank you, Morris. Thank you for that. We've had a great question that's come in from for you, Darren, from Colin, also in Queensland, asking you: copper theft is now a significant consideration when specifying cable trunking systems and service enclosure. What considerations do you take into account to eliminate or reduce the risk of copper theft due to unauthorised access? Darren.
Thanks, Colin. That's a very topical question at the moment. I think in last week or two, I've actually seen a news article in Sydney where there was on Parramatta Road at night, there was a car that was pulled over, and it was actually filled up with copper pipes and copper wires. The police pulled them over, they pulled out all the things and laid them out, and there was just a whole lot of copper. So there is a market out there for copper resale. Sounds like they can make a lot of money from it. And that is a very interesting, I suppose, topic for especially asset owners who, if if these copper gets stolen from the assets, it's a lot of issues with replacing. It's very costly, so you need to find ways to secure your assets. And there are a lot of different products that are available, providing different levels of security. At ACCO, we've got our power lock lids. Our power lock lids come standard with a locking bolt, just a hex head or a Allen key bolt. But that bolt can be replaced with a security bolt, so like a Barry bolt type of security bolt where you need a special key to unlock. If you want additional security, you can add a padlock. So a padlock with a master key for, I suppose, that's unique for that asset owner can be used. And then, ACCO also supply SCEC, the highest level of protection. So the SCEC ones we actually sell to the Department of Defence, but and all government agencies to protect their data and cabling through the major cities and around Canberra. So these are actually available also for other asset owners if they want. And also, with ACCO, we are actually talking to a lot of the road authorities around the country in each state and helping them develop more secure covers. And it's just because of the, I suppose, the widespread amount of theft in copper, and it's just not confined to any particular area in Australia. It's actually all over, we've heard. So we're actually working with the MRWA in South Australia with DIT. We've designed a standard secure cover with them. Also working with the TMR in Queensland and even other energy providers to help secure their assets. So definitely we can offer different security levels, or we can even develop a special security feature to lock down for your asset owner.
Thank you for that, Darren. Morris, we've had a question that's come in talking about brownfield sites, and we're still in Queensland. It's coming from Lauren. I hope the weather's a bit warmer up there than here in Melbourne. Morris, the question is, how best can we coordinate underground services on brownfield sites where as-built drawings may be incorrect? Morris, I'll start with you, and Darren, you may want to comment on that one too. Morris.
That's a good question. Yeah, thanks for that, Lauren. The best way to do that is to provide a site survey and use ground penetrating radar that actually locates all of the services in the ground, and the people that offer that service will mark on the actual surface where the various services that they locate under the ground, and I guess there's always the issue of I guess convincing the client that's warranted. I mean, often you might think a particular service is in a particular location, but if you've got some other new work and some civil work going on, and you think you've got a 1.5 metre clearance, and they start digging with their bucket and they find that it's not that not that amount of distance. So yeah, there's definitely expense associated with doing a ground penetrating radar survey, but it's a risky exercise. If you understand the risk of hitting a particular service, you might have a general idea what's underneath there, and obviously the consequences that it might not only be affecting your side, it might be affecting many people along the street line or somebody else. So it's it's good practice to do a site survey with ground penetrating radar to locate those services.
Thank you, Morris. Darren, anything to add?
Yeah, look, totally agree with Morris on all his comments there. Yeah, it is a challenge, especially in the built-up environment in major cities where there are a lot of services in the ground. Could be sewage, could be stormwater, water, gas, electrical, communications. You've got everything in the ground. So I suppose when that's the worst case. I suppose in all the built-up areas. When you get out, I suppose further out in the metropolitan area, there's less out there. But yeah, totally agree with what Morris said. Do your risk analysis, do your searches, and and make sure what you're digging. Carefully dig as you go to see if you can expose those, and then your challenge is to design around what's there, because we all know that relocating services is a very expensive exercise.
Thank you for that. Darren, we've moved away from Queensland. Questions coming from Kenneth in New South Wales, asking you, Darren, how do asset owners and project engineers balance the need for long-term durability and safety of cable enclosures with the increasing pressure for faster project delivery and cost efficiency, particularly in high traffic urban environments? Thank you, Kenneth, for that question. Darren.
There's a lot of a lot into that question, Kenneth, but I'll try my best to answer it. I can feel what you're feeling from the asset owner with all their requirements. They want a durable, long-lasting solution. They want it to be safe, and for the cable enclosure, they want to install it very quickly, and then you've got to work around an environment that is really moving along. So it is a challenge, but I think as a designer, what you want to do is review the location, understand the application, the vehicle loads, any traffic, and then select a product that is durable, and then detail it accordingly. So hopefully you select a product, and then the manufacturers have standard details which you can easily download and apply to your application. And also make sure you select, take into consideration all the issues in regards to maintenance, what the asset owner requires, pedestrian safety, and all those. And if you've taken all those considerations, you've done as much as you can. And then I suppose coming looking at precast options that can be easily installed quick on site would be the best option.
Thanks, Darren. Questions come in, Maurice from Gamma, asking, what is a typical MV pit size?
I don't know that there is a thing such as a typical MV pit size. It's all to do with the size of the cables and the duty of the load. So the more current you want to draw within your cable, the bigger the diameter of the cable, and hence the bending radius is longer, the higher bending radius. And when you're trying to do that 90-degree bend within the pit, then that's where the pits slowly get bigger and bigger. So I wouldn't say there is a typical pit size, because the design is typically based on the capacity of the cable and the bending radius. So I wouldn't say there is such a thing as typical. You've got to look at each application in its own right.
Thank you, Maurice. And just staying with you, Maurice, we've had a question coming from Michael asking, on the LV foundation and pavement penetration side, there was a large D-link plate on the inside of the pit wall. What was the purpose of this, and is it load related? And Raj has also asked a question, just asking us to clarify what is LV and NV. Thanks, Maurice.
Yeah, well, addressing that first one, it's a good question. And initially, I thought to myself, well, I didn't quite know what it would be for, but I think I can surmise that it could have been in there as a temporary solution for when they're using pulleys or for because when they actually install the cables, they fit temporary equipment inside the pits. They could have been an anchoring point for when they were pulling the cables. So that's my best suggestion there. I'm not too sure of the actual kg rating and the loading of that. And with respect to the MV, that's a good question, because I've used the term MV as opposed to HV, because in our sort of engineering world, there is a distinction that the people, the MV typically is in that 11 kV and 22 kV sort of area, because and then HV is above that, above the 33, 66, 110, and then the LV is considered anything effectively from 400 volts and below. Might even be
Thank you,
sorry.
Maurice.
Yeah,
Yeah,
thank you.
thank you. Darren, we've had a question come in asking you for a custom designed electrical pits. What are the consideration for the pit wall thickness design? Thank you, Darren.
With custom designed pits, they're usually the bigger sized pits. With smaller size, your smaller 450 by 450, 600 by 600, 900, 900 clear opening pits are your common size pits. Once you start getting bigger than that, you're starting to look at custom sized pits, and these are to gain access to large openings for maybe there's many conduit entries as shown in Morris's presentation, or they can be need access to put a substation in underground under a platform or something like that. So with these custom design electrical pits, these are more structurally designed. So it's really, you probably have to go to a structural engineer who will detail the reinforcing that's required. These are commonly cast in situ pits in these areas. So, it'll be structurally designed to take the loads. And then, with the access covers, there'll be pockets to put beams in. So you just got to design to allow for these pockets. So ACCO, we can provide these big, large rhino cast multi-part cover systems. They could be up to 3 meters by 3 meters clear opening, or even bigger, and they'll contain 2 or 3 universal beams that need to be lowered into these to support the smaller single part covers. So with our products, our single part covers, they're all being tested to the AS3996 requirements, and our beams that we specify into these multi-parts, they're all being certified by a structural engineer. So you can be reassured that if you purchase a multi-part or design a multi-part from ACCO, that we can back it up with electric engineers certification and testing.
Thank you for that, Darren. Morris, we've had a question from Narendra, who is watching in Victoria. Good afternoon to you, asking, some power cable pullers ask for very large draw pits, stating that it is required for especially larger diameter power cables. This is a huge challenge for civil engineers if the draw pit size requested is, say, 3 meters by 3. Is there any way cable pullers can do their work without the use of extra large draw pits? Thank you for that, Narendra.
Yeah, thank you for that. Yeah, I guess I pondered this one because this was I thought it was quite a tricky one. It was one of the ones that was asked before the presentation. And I guess the short answer, if it is an installation and the cable and everything has been specified, then there's not a lot you can do, because you can't exceed the cable manufacturer's bending radius, you could damage the cables. So putting my electrical hat on, I would have considered other potential design solutions that could, instead of, I don't know what these cables are, but instead of having one large multi-core cables, could you potentially use smaller single core cables that would have a smaller bending radius, and hence you could make that 3 meter by 3 meter bit smaller, technically, or alternatively, could you, from an electrical perspective, run multiple small cables in parallel? Again, that will bring the size of those cables and the bending radius down, making the pit slightly smaller, but you will have to take into account the spacing and the heat dissipation and the grouping factors associated with that cable. Also, it might be a good idea to talk to the client, and through your safety and design procedures, you could, is it possible or potential to maybe bury that section, or have some of that section as a buried direct, in the example I gave earlier, where there was some compromises made with respect to the need for the conduit. So, yeah, there's a few workarounds there, but certainly I don't think there's any shortcuts. You don't want to be exceeding those bending radiuses. You're spending a lot of money on these copper cables, very large, expensive cables. The last thing you want to do is to damage them as you're pulling it in. Or exceeding those limits, you could potentially talk to the cable manufacturers to see whether there's any tolerance on those bends. But yeah, that's some suggestions that I thought of.
Thank you for that, Morris. And we are getting to the end of today's session. So it would be great. We've covered a lot this afternoon. If, starting with yourself, Morris, and then you, Darren, you could just spend no more than 2 minutes just summing up the key takeouts from your presentations for our audience today. Thank you. Morris, take it away.
Yeah, thank you for that. Well, the key takeouts, for me, from an electrical point of view, is the number of options that are available. Certainly, understanding the limitations of your systems, and also I would emphasize talking to your client and understanding their needs as well, and understanding the role of that conduit, why you're using conduit as opposed to direct buried, making sure you get those segregation issues and compliance issues, nailed down. They definitely don't want to ingress into anything that's marginal, allow for a margin of error, and yeah, that would be some of my key takeaways. There's certainly lots of products and different ways of doing things. So yeah, talk to your suppliers, and because there's a lot of solutions and different ways of doing things.
Thank you for that. Darren.
Okay, thanks everyone for attending this webinar today. Hopefully you got something out of it. So my key takeaways from this is for the designers, always understand the application, what the requirements are, the site requirements, the project requirements, and obviously the asset requirements, asset owners' requirements. And then design accordingly. So make sure you specify the product, looking at the different features that's required for the application. So if it's in a pedestrian area, slip resistance of the top of the cover is important. The loading on if the cover or pit is located in a roadway or in a driveway, how the movement of the traffic is going to affect the product. So ensure you look at pits and lids and covers that meet those requirements. So look, the most important thing is just to make sure you specify the product with a product that meets all those requirements. Don't leave it to chance, up to the contractors on site to be very vague on the specification and up for interpretation. And if you specify something and meet with all those requirements, it'll be a long-lasting, durable product. So yeah, definitely detail it. The level of detailing is very important. So my key takeaway is just make sure you specify it, and you can come to ACCO where we can help with a lot of backup information, a lot of technical data, and especially a lot of backup in regards to NADA endorsed test reports for our products, and our large library of installation details and technical support down to installation instructions. So with that, before I end, as a very proud New South Wales Welshman, I can't let Morris get away with his second last slide, which in fact had a blue background. So, go the Blues tonight. Hope for a great game. Thanks all.
Thank you, Darren. Yeah. Where's my scarf? Where's my scarf?
Thank
Nice
you
one.
to everyone. This session has gone past so quickly. Today we've been talking about integrating service enclosures in slabs and pavements. And please, once again, join me in thanking Darren Chan and Maurice Belcher for giving up their time and input today. Before we wrap up, I would like to share a competition question from ACCO. And if you could please share your answers to the email on the screen and in the description box below. In 150 words or less, if you were designing a cable route in a public urban space, how would you guide the client? Just quickly, I'd like to share that Engineers Australia's Excellence Awards 2025 are up and open. A great way to recognise your people and projects driving innovation. You can nominate yourself or a peer or a standout team member by scanning the QR code on screen. As always, if you can spare a couple of minutes or less to complete a short feedback form, which is linked in the description box below. As always, it helps us improve and plan for future sessions. Thank you again for joining us, and I look forward to seeing you at our next Industry Partners event. Thank you and good afternoon.